Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on SCR commutation, in that Class E and Class F commutation. First here, the SCR commutation means here the turn-on. SCR is a semi-controlled device. The turn-on is in our hand when you give the positive supply to the anode and negative supply to the cathode, and if you give the gate pulse and it will be turned on, that is in our hand. So when you give the gate pulse, once it is latched and it will be turned on, it will go from forward blocking mode to the forward conducting mode. So but it will not turn off. Turn off is not in our hand. So here for that, so here anode current should be below the holding current. Either anode current should be below the holding current, or either anode current should be less than the holding current, or apply the reverse potential to the SCR. These are the two methods to turn off. So this is the current commutation, and next if you apply the reverse potential to the SCR, that is the voltage commutation. Now here there are two types of commutations. First one is a force commutation and second one is a natural commutation. If you give the DC supply to SCR, so that is forced commutation. In this LC components we will use. So now here natural commutation means here we are giving AC supply. So here AC supply means here in the reverse bias condition SCR will not be conduct. So here this is natural commutation. In the forced commutation we have again 5 types of commutation: Class A commutation, Class B commutation, Class C commutation, Class D commutation. So all these Class A and Class B, Class C and Class D already we discussed, and today I am going to explain Class E, and under the natural commutation, Class F commutation we will study. Class E commutation means that is external pulse commutation. So now here Class F commutation means that is natural commutation or line commutation. So line commutation. So now here the circuit diagram. First I will explain Class E commutation. In the Class E commutation, first the main thyristor is a T1. So here this is the main circuit. So here this is plus and minus VS supply. So DC supply we are giving means that is forced commutation. Now here this is the actual circuit. This is thyristor T1, and next here this is supply we are giving VS, and next this is the load. So T1 current. Now here current is flowing. I0 current, IT1 current, I0 current is flowing, and this is a supply plus and minus forced commutation. So now here we have given positive supply to this anode and cathode, and this we are given gate pulse, and the thyristor is turned on. So turn on is okay. So now we need to turn off this. Our job is to turn off this. T1 should be turned off. So here T1 should be turned off means here what are the components? Our external components are required to turn off the forced commutation. It is a Class E is a under forced commutation. Here we need external components. For natural commutation it does not require any commutating elements. So here to turn off this SCR T1, so we need external components. So T2 and T3 are the auxiliary, means external thyristor SCR1, SCR2 and SCR3. So these two thyristors are used to turn off this SCR, and another components are L and C. So this is the capacitor and this one is the L, and another one is the auxiliary voltage source, auxiliary supply, auxiliary supply, that is V1, and this is load. So these are the components T2, C, L, T3 and V1 are the external components to turn off the T1. So now see the actual scenario: T1, T2, T3, L, C, and this is the load. Suppose this is R and this one is plus and minus. This is actual circuit diagram for class E circuit. So this is a commutating circuit. So now here to turn off this T1, so first fire T3. So T3 should be on. So T3 is on means here, so this capacitor is charging. This already it is turned on, and here to turn off this, so T3, to turn off this T3 must be on. So T3 must be on means here current flowing here in this direction and this capacitor is charging. So this capacitor current IC equals to V1 into square root of L by C by L. So V1 by L. So now here at pi equals to at T equals to square root of LC, it is turn on this T3. So now here this one is the T equals to pi into square root LC. So now here capacitor is charging means here this T3 is self, now here it is charging up to 2V1, up to 2V1. So it is charging up to 2V1. So now here, so this value is 2,1 means it is this value is greater than this supply voltage. So now here this value is greater this value. So Vs is always 2V1 is always greater than V1. So now here what I will do, so now here this T3 will be turned off, self-commutated means this 2V1 it is charging up to 2V1 and here this T3 is self-commutated. So now it is self-commutated means here we have only this is open circuit and this is 2V1. 2V1 means here this voltage is V1. Now fire T2. Now fire T2 means here now turn on this one. Now it is open circuit. Now it is open circuit, turn off, and now fire turn on T2. So now what I turn on T2 means this voltage. So this turn on this voltage means here this load voltage equals to Vs minus 2Vs. Vs minus 2Vs means here this voltage equals to 2Vs, and now here this voltage here Vs minus 2Vs voltage, Vs minus this 2Vs voltage applied across TV1. When you turn on this T2 and Vs minus 2Vs is applied across the T1. So now here 2Vs is always greater than Vs means negative voltage we are applying to this T1. So now here this T1 is turned off. T1 is turned off means here in this way T1 will be done. Initially initially T1 is a main thyristor and T2 and T3 are auxiliary thyristors. So initially voltage we are giving to this T1 and current flows to this load. So to turn off this T1 we are using T2, T3, V1, L and C components we are using. So now first fire T3 to turn off this one. T3 turn on means here at T equals to pi into root LC. So current flows in the inductor and capacitor, and here it is capacitor is charging, that capacitor current equals to V into square root of L by C. So it is charges up to 2V1. So now here this is 2,1 means, so this T3 this voltage, so here this T3 is self-commutated automatically when it is turned on and it is turned off, and this capacitor discharges. and now here this voltage 2V1, this is 2V1. So now here again T2 is turned on. T2 is turned on means here, so this voltage is same voltage applied here. This is 2V1, sorry, not 2Vs, 2V1, and this is 2V1, and now here this 2V1 is always greater than this Vs, and now here this Vs and 2Vs applied across this one. This is reverse potential, negative potential we are applying to this one. Now T1 is turned off. So in this way T1 will be turned off. Now if you see the graphs, here what are the graphs? T1, T2 and T3, L, C. This is the load. So now here V1 plus and minus and plus and minus. So now if you draw the graphs, here this is a fire gate. If we are giving gate pulse IT G1, so here we are giving the gate pulse to this one, and next second we are to turn off this one, and IT 3 G3. Okay, na, this fire we are firing here. So here when we are giving, so now here this current equals to this capacitor voltage equals to, and next this VT1 voltage. VT1 voltage somehow here, and now capacitor is charging when it is this one, and when it is T3, so capacitor is charging. Okay, now at T equals T1 capacitor is charging, and now here it is reaches to 2V1. It is reaches to 2V1, and again when it is turn off means again T2 is automatically it is turned off, and when it is to T2 and it will be turned again it will be discharges. So charges and it is discharges, and next here T2 to turn off this, again at T2, so capacitor is discharges, and this voltage, and it is T2, and this voltage is applied across this one, and it will be T1 should be turned off. So T1 should be turned off means here so Vs minus V0, so this is T2. So now here we are applying Vs minus 2V1, we are applying to the T1. So now here the reverse potential we are applying to this one. So what do you mean by turn off time? So T off equals to turn off time is equals to, turn off time means here, what do you mean by turn off time? The time for which the SCR is in reverse bias. So now here T2 minus T off, T2 minus T1 is a T off. So during which thyristor will be in reverse bias. So now here what I will do first, I will determine this T off time. So now here Vs minus 2V1 we are applying to this one, and 1 by C integral of I0 T2 minus T1 or T1 minus T2. So now here, sorry, this is T1 and this is 2, and 1 by C here I0 into T2 minus T1. So Vs 2V1. So now here this is T off. This is T off means, so T off is equals to T off, turn off time equals to Vs into minus 2V1 into C by I0. So this is the circuit turn off time, SCR turn off time. This values depending on the load voltage. So this is values load voltage and capacitor and auxiliary voltage supply, and this one. This is regarding class C commutation. In this way SCR will be turned off. So now here natural commutation. Under the natural commutation category, only one. So here in natural commutation means here we are giving AC supply. In the previous class A, class B, class C, class D, class E, so we are giving DC supply. So for that case, we are using external components that are LUC, auxiliary thyristors. We are using to turn up. Again, diodes also sometimes we are using. So to turn up, we are using external components to turn off the SCR. But here it does not. In natural commutation, it does not require any external source. So now here, so this is AC supply we are giving to this SCR. So SCR, we are giving AC supply to this SCR, and now here this is our load resistor and current flows in this direction. So now here when you give the gate pulse only, it will be turned on. So first this is supply voltage. This one is supply voltage. This is supply voltage. Vs equals to Vm sin omega t. So Vs equals to Vm sin omega t. This is the equation. So we are giving AC sine wave, single phase AC supply to this SCR. So now fire Ig. So now fire Ig. So gate pulse. I am giving gate pulse at suppose alpha I am giving. So this is forward blocking mode. Forward blocking mode. So when you give the gate pulse, so it will be in the forward conducting mode. So now here we are getting output voltage. So this is the output voltage. It follows the supply voltage. This is the supply voltage is 0. We are not giving any gate pulse. This is in forward blocking mode, and this one is the forward conducting mode. So now here when you give the reverse potential to this one, sorry, this is I think here only. Here only. So now I am giving the reverse potential to this one. Reverse potential. So now I am giving the negative during negative half cycle. So thyristor will be in turn off, that output voltage value is 0. So now here 0 to alpha, 0 to alpha, 0 to alpha, 0 to alpha. So Vs is greater than 0, Vs is greater than 0, and Ig is 0, Ig is 0, and it is in forward blocking mode, and output voltage is 0, output voltage is 0, and output current is also 0, and next supply Vt equals to the supply voltage. Now this voltage equals to Vs equals to Vt, and next Vs minus Vt, that equals Vs only, because output voltage is 0. Now in the second mode is a forward conducting mode, so it follows the supply voltage. So when alpha to pi only, up to pi it will conduct. So this voltage we are giving, and Vs is greater than 0. Ig, we are giving the gate pulse not equals 0. We should not give any negative pulse to this one. So Ig must be greater than 0. So now here Ig should be greater than 0. So now it is in forward conducting mode. In this mode, so Vs equals V0 here in this. So it follows the supply voltage. So I0 equals to this voltage by this load resistance V0 by R, and this voltage equals to, so this thyristor voltage equals to, it follows this voltage means Vs equals to V0 means here this voltage is 0. And next reverse bias, this is important. We are turning off this SCR under the natural commutation. Automatically it will turn off. It does not require any external components. So now here pi to 2 pi, pi to 2 pi, pi to 2 pi here. So Vs is less than 0. So Vs is less than means we are giving reverse potential, and Ig value is 0. So in that case thyristor will be, SCR will be in turn off, and SCR will be turn off means that V0 equals 0, and V0 equals 0 means I0 equals 0. I0 equals 0 means, so now this is, it follows the supply voltage. Vt equals Vs minus V0, and V0 is 0 means it follows the supply voltage, again reverse potential. This is thyristor voltage. Vs Ig, V0, I0, Vt. So now here we can conclude that here during a positive off cycle from alpha to pi, thyristor will be turned on, but during negative off cycle, so the SCR will be in turn off position. So automatically it will be turned on when we apply reverse potential to SCR. So this is the natural commutation. Natural commutation. Commutation, or another name is the line commutation. Line commutation. So now we have completed all six all forced commutation and natural commutation. Class A commutation. Class A commutation means here that is load commutation, and class B commutation also we have completed. Class B commutation means current commutation. Current commutation. Current commutation. This one is a voltage commutation. Sorry, this one is a voltage commutation. Parallel or parallel capacitor. And this one is a external pulse. External pulse commutation. This one is a line commutation. This one is a complementary commutation. So all these we have completed. So in the class A commutation, this is the this is plus and minus only. This one is the only this is DC supply. This is for AC supply. So here we are giving this T1 to this SCR. So this is the load. Here L and C are the L and C are in the class A commutation. In L and C are the commutating elements. So here, so under the underdamped condition, the system, it is a RLC circuit. So in this when it is a underdamped condition, the zeta must be less than or equals to 0 to 1. So in this case, so the circuit must be the system system response must be I0 should be in this way. Here at this negative position, so the SCR will be in the turn off. So we need to make this system in underdamped system, then only it will be turned off. So here there is a procedure. And next, class B commutation. In the class B commutation, so first current flows in this T1 to this one. So here load current is constant I0, and next here capacitor voltage initially charges to Vs, and next here another one is the LC circuit is resonating in nature. So first here what I will do, current flows in this direction and T1 is turned on, current flows in this direction. To turn off this T1, so first what I will do, turn on this auxiliary thyristor TA, and LC circuit is resonating in nature, and it will be negative. It will be negative means here, so now this is forward bias, so this diode will be in forward bias and current flows in this, and it is flows and current flows in reverse position. This is current commutation. So now here when anode current is less than the holding current, this SCR will be turned off. So now complementary commutation means here initially T1 and T2 are turned off. So first turn on T1. So to turn off this T1, so here supply voltage we are giving to this one, current flows in this direction, and again current flows here in this, and here this is Vs. So now here to turn off this voltage, so we are applying this voltage. So now here this is minus and plus. So now here this voltage reverse potential we are applying to this one. This is short circuit, this voltage we are applying here. So T1 will be half. Same way here, this one, this is minus and this one is plus. So here in this case, so now turn off, to turn off this one. So now here current flows in this direction here, and again another current is flows here, and next here to turn off this one. Here we are applying to this reverse potential to this one. So this Vs voltage and T2 will be turned off. Next, class D commutation. In the class D commutation, what I will do, this is T1 and this is T2. So now here T1 current flows in this direction and turn on T2. So turn on T2 means here. So here current flows. Here what I will do, so current flows. This is Vs voltage. Turn on T2 means here turn on T2. Voltage current flows in this is Vs, and this voltage turn on T2 means here this voltage and it is flows here, and here current flows in this direction, this voltage, and here, and it will be T2 is turn up and this turn on. When you turn on this, and here this will be reverse voltage we are applying here. This voltage commutation T1 will be turned off. So here this is already we discussed T1, T2 and T3. So first to turn off this one, T3 must be turned on. It will be charged up to 2V1, and next here it will be self turn off, and next again T2 is turned on, and Vs minus 2V1 will be applied across this one T1, and T1 will be in reverse biased and it will be turned off. So in the class F commutation, when you give positive supply, it will be turned on, and when you give the reverse potential pi to 2 pi, it will be turned off. So these are the commutation techniques. So total class A, class B, class C, class D, class E, class F. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.